Transport infrastructure for Europe, the new bridge over the Danube between Bulgaria and Romania. In 2006, selected by the Bulgarian Ministry of Transport in an international bid, FCC Construction was awarded the design and construction of the Danube Bridge 2, as well as its accesses including 2 railway stations for passengers and goods. These constructions have been jointly financed by European funds and by the Bulgarian state. The bridge connects the towns of Vidin, Bulgaria, and Calafat, Romania, but its real importance goes far beyond that, as it joins the pan-European transport corridor by road and rail, which goes from Germany to Turkey, besides being the second bridge over the Danube in the more than 650 kilometers of the border between Romania and Bulgaria. The contract was signed in March 2007. The work began in November 2008 and finishing the construction at the end of 2012. On the Bulgarian bank, the 4-lane motorway and the railway tracks meet, the latter coming from a higher level. Joined on the bridge crossing into Romania, the road opens in the center for the railway track, and both continue at the same height, first over a non-navigable stretch of the river and after over the navigable channel. The bridge is 1,791 meters long, with a unique unsymmetrical deck with 2 exterior 4-lane roadways totaling 15 meters, 1 central railway platform of 6 meters, 2 pavements and 1 bicycle lane, which make a total of 31,35 meters in width. The motorway is designed for a speed of 100 kilometers per hour with a maximum slope of 4%. For the railway, however, the speed is 160 kilometers per hour and its maximum slope 1,25%. The bridge is divided into 3 distinct parts. The railway access bridge. It's 772 meters long, which comprises a span of 32 meters, 13 spans of 40 meters, and 220 meters of transition between the railway structure and that of the bridge over the non-navigable river channel. Built in situ by means of a scaffolding truss, it's composed of a post-tensioning concrete deck with a transversal section in the shape of pi and a platform width of 8,6 meters with a constant thickness of 1,89 meters out of the transition area. The deck is held up by 13 double piers, whose shafts are circular reinforced concrete pile piers of 2 meters in diameter. The length of the piles varies between 35 and 61 meters. The bridge over the Danube in its non-navigable stretch. With a length of 646 meters, its deck is made up of a central caisson comprising precast segments of concrete 2,15 meters long, 4,5 meters thick and 10,9 meters wide, and exterior wings resting on struts every 4,3 meters. Mounted on each pier by the balanced cantilever system, they have a longitudinal pre-stressing within, which connects them, passing through the upper and lower slabs. The spans are 80 meters long, except for the first, which is 52 meters long. It's supported by 8 concrete piers in box sections and variable height of up to 20 meters, bounded in pyramidal pile caps of 15 by 15 by 4 meters and 6 or 7 piles of 2 meters in diameter, with lengths between 55 and 72 meters. Bridge over the Danube in the navigable channel. It's 745 meters long, spread over 3 central spans of 180 meters and 2 lateral ones of 124 and 115 meters respectively. It has 4 concrete pylon piers with a variable height between 39 and 45 meters, founded in pyramidal pile caps of 15 by 40 by 6 meters, which support in 24 piles of 2 meters in diameter and lengths between 61,5 and 80 meters. The deck is equal to the non-navigable stretch, also mounted in each pier by balanced cantilevers, but from the river and with segments much larger and heavier. 4,18 meters long and 250 tons in weight. Besides the internal longitudinal pre-stressing, due to the greater length of its spans, it requires an extra-dosed pre-stressing which comes from the upper slabs of the segments and is anchored to the pair of pylons 22 meters high in each pier. The piers have two longitudinal struts which, coming from the pile cap with an inclination over the horizontal of some 55 degrees, hold the deck being embedded in it and improving the function of the stays of the extra-dose system. For the protection against the impact of vessels, each pier has 38 precast concrete pieces of between 85 and 135 tons installed, joined to the pier by a pre-stressed grillage, and between them with reinforced concrete tie beams cast in situ. To carry out the building works, both for the bridge and the accesses, FCC built a machinery and equipment park 3 kilometers downriver from the bridge, with a total surface of 22 hectares. In it there was available, amongst other things, 5 segment fabrication lines with the necessary infrastructure for the production, distribution and cast-in place of the concrete, steam curing, steel work base, manipulation and stockpiling of the production. There were also